Welcome to Thought Frontier.
Welcome to our deep dive into the fine-tuning of the universe.
Oh, cool.
So we're basically tackling the age-old question,
Yeah.
is our universe's existence just some incredible coincidence, or is there something more at play here?
I mean, that's a question that's fascinating. Physicists, philosophers, theologians,
Right.
for centuries.
Yeah, it's a big one.
Absolutely.
And your sources really offer some compelling perspectives on this whole debate.
For sure.
So before we get into the multiverse and all that really mind-bending stuff,
Right.
let's make sure we're all on the same page.
Yeah.
When physicists talk about fine-tuning, what exactly do they mean? It sounds like, adjusting a radio dial or something.
That's actually a great analogy.
Really?
Yeah. So imagine a universe where the fundamental constants,
Okay.
like the strength of gravity, the mass of an electron, or the speed of light, are like dials on a giant control panel.
Okay.
And the values of these constants are incredibly precise.
Okay.
If they were even slightly different,
Yeah.
the universe as we know it might not exist at all.
Wow.
No stars, no planets, no us.
That's kind of freaky to think about.
It is. It's a pretty profound concept.
So it's not really about proving or disproving the existence of a creator or anything.
Right.
But rather exploring this idea that the universe seems remarkably well suited for life, even if we don't know why yet.
Exactly.
So what are some of the most striking examples of this fine-tuning that you found in your research?
Well, one that always kind of jumps out at me is the Hoyle resonance.
Okay.
It's this very specific energy level in the carbon atom
Okay.
that allows stars to produce carbon, which is, the very element that forms the backbone of all life as we know it.
Right. Yeah.
And what's really fascinating is that the astrophysicist Fred Hoyle
Okay.
actually predicted this resonance
He did?
before it was even observed.
Oh, wow.
He knew that stars needed some way to overcome this energy barrier
Okay.
to produce carbon efficiently.
Yeah.
And he was right.
I mean, that's incredible.
It's pretty amazing.
That he predicted that.
Yeah.
So without this incredibly precise energy level, stars wouldn't be able to create carbon
Right.
in abundance.
Exactly.
And life as we know it wouldn't exist.
It really highlights how delicate the balance is.
Right.
Yeah.
It makes you wonder, how many other seemingly insignificant details are
Right.
actually critical for our existence.
That's a great point. You're hitting on a key point there.
Yeah.
It's the interconnectedness of it all.
Right.
Another example is stellar stability.
Okay.
It's this delicate balance between gravity and nuclear forces within stars.
Oh.
If gravity were just a bit stronger,
Yeah.
stars would burn out super quickly.
Oh.
If it was weaker, they wouldn't even ignite at all.
Oh, wow.
Yeah.
So it's like this cosmic balancing act with these forces
Yeah.
in perfect harmony to allow stars to, exist for billions of years,
Yes.
giving life a chance to evolve.
Right.
Now, I know one of your sources is Victor Stenger,
Uh-huh.
who argues against the fine-tuning argument.
He does.
So how does he explain these seemingly improbable coincidences?
Well, Stenger doesn't deny the importance of these physical constants for life,
Okay.
but his argument is that many instances of apparent fine-tuning can be
Yeah.
explained by, the physics and cosmology we already understand.
Okay.
He advocates for a more holistic view,
Okay.
like looking at the interconnectedness of all these parameters
Yes.
and arguing that perhaps life is possible under a wider range of conditions than we currently assume.
Interesting. So instead of saying wow, look how perfectly tuned everything is, he's saying, hold on, we might not be seeing the whole picture yet.
Exactly.
Yeah.
He also emphasizes the importance of Occam's razor.
Oh.
The idea that the simplest explanation is usually the best.
Okay.
So he sees invoking the multiverse or a creator as adding unnecessary complexity
Right.
when there might be simpler explanations within our current understanding of physics.
So to put it another way, he's not ruling out the possibility of fine-tuning.
Right.
He's just saying, let's make sure we've exhausted all the other avenues before jumping to,
Exactly.
more radical conclusions.
Yeah, he's urging caution and a thorough examination of all the possibilities.
Okay, and now your other source, Luke Barnes,
Yes,
he offers a counterpoint to Stenger's arguments, right?
he does. Yeah.
So what are some of his key disagreements?
Well, Barnes takes issue with Stenger's assertion that the universe isn't fine-tuned.
Okay.
He argues that Stenger oversimplifies the fine-tuning arguments,
Okay.
and that he doesn't really give enough weight to the precise interplay of multiple factors that are required for life.
Right.
So he digs into the complexities of cosmology,
Yeah.
astrophysics, and particle physics to counter each of Stenger's points.
So while Stenger's saying we should stick to explanations within our current understanding,
Right.
Barnes is arguing that the level of fine-tuning is so precise
Yeah,
that it points towards the need for a wider explanation,
exactly.
possibly something beyond our current knowledge.
That's his perspective.
Yeah.
Yeah.
Okay, so that's really interesting.
It is.
Because you've got these two very different perspectives
Right.
coming at it.
Absolutely.
And this leads us to one of the most intriguing and controversial solutions
Yes.
that's been proposed to address this whole fine-tuning problem.
Right.
And that's the multiverse hypothesis.
Exactly.
But before we dive into the multiverse
Mm.
and all of its kind of mind-bending possibilities,
Right.
let's take a closer look at some specific examples that both Stenger and Barnes use to support their positions.
Sounds good.
So let's start with star formation, because that's a good one.
Sure.
We'll get into that next.
Okay, sounds good. So one area where Stenger and Barnes really clash is on the fine-tuning of star formation.
Oh,
Yeah, it's a super complex process
Right.
involving this delicate interplay of gravity, nuclear forces, and the abundance of elements in the universe.
so it's not just about a star igniting, it's about all the conditions necessary for stars to even form in the first place and
Yeah.
then live long enough
Right.
to create the heavier elements that are the building blocks of planets and
Yeah.
ultimately life.
Precisely.
Mm-hmm.
Stenger argues that while life as we know it might be impossible if certain constants were different,
Yeah.
other forms of life might thrive in those alternative universes.
Oh, interesting.
He suggests we might be biased by our, carbon-based perspective on life.
Oh, that's fascinating.
Yeah.
So he's not saying the universe isn't fine-tuned. He's
Yeah.
just saying it might be fine-tuned for a much wider range of life.
Exactly.
Yeah.
Than we can currently imagine.
Yeah, he challenges us to think outside of our...
Like beyond our human perspective.
Yeah, like he uses this analogy of looking for fish in the ocean.
Okay.
And assuming that all fish breathe air,
Okay.
we could be missing an entire universe of life forms that function in ways we haven't even considered.
That's a great analogy.
Yeah.
It reminds me of how scientists used to think that life couldn't exist in the deep ocean
Right,
because of the lack of sunlight.
right.
And then they discovered hydrothermal vents teeming with all these bizarre creatures.
Yeah, totally.
So how does Barnes respond to this idea of alternative life forms?
Well, Barnes acknowledges the possibility of, these other forms of life.
Yeah.
But he argues that even if life could exist under a wider range of conditions,
Okay.
the probability of those conditions arising is still incredibly low.
Okay.
He points to the specific values of constants like the gravitational constant, the strength of the electromagnetic force.
Arguing that even tiny variations in these values
Right.
would have resulted in a universe where stars either couldn't form at all
Right.
or wouldn't live long enough to produce the elements necessary for any kind of complex chemistry,
Right.
let alone life.
Yeah. So while Stenger focuses on the potential for this wider range of life-permitting conditions,
Right.
Barnes is emphasizing the extreme improbability of those conditions actually occurring.
Exactly.
It's a fascinating contrast in perspectives.
It is.
Yeah.
And this brings us to the multiverse hypothesis,
Okay.
which offers a way to address this improbability problem.
Okay. How so?
Well, the idea is that if there are countless universes,
Okay.
each with its own set of physical laws and constants,
Okay.
then it becomes statistically more likely
Okay.
that some universes would just happen to have the right conditions for life to arise.
So it's like winning the lottery.
Yeah.
If you buy enough tickets, your chances of winning increase dramatically. But instead of winning money, the prize is a universe capable of supporting life.
Right.
Okay, but the multiverse hypothesis is not without its critics, right?
Oh, absolutely.
Even among those who accept the idea of fine-tuning.
Yeah.
So where do the problems lie?
Well, part of the challenge lies in the what's called the measure problem.
The measure problem.
Yeah. If there are infinite universes with all these different properties,
Okay.
how do you even begin to calculate the probability of our universe existing?
Right.
It becomes this kind of mathematical and philosophical quagmire.
So it's like trying to compare apples and oranges,
Yeah.
but on a cosmic scale.
Exactly.
You've got infinite sets of universes with potentially different laws of physics,
Right.
making it nearly impossible to determine which universes are more likely than others.
Precisely.
Okay.
And this is where Stenger brings in Occam's razor again.
Oh, okay.
He argues that the multiverse introduces this level of complexity that's just not necessary
Okay.
to explain the fine-tuning we observe.
So essentially he's saying, let's not overcomplicate things.
Right.
We might be able to explain this with simpler solution.
Exactly. Stick to what we know.
Right.
Yeah.
But Barnes argues that even within our own universe, the fine-tuning is so precise
Yeah.
that it points towards the need for a wider explanation,
Right.
like the multiverse.
Exactly.
He believes the evidence for fine-tuning is just so compelling that it warrants considering explanations beyond our current understanding.
He uses this great analogy of a detective investigating a crime scene.
Okay.
If all the evidence points to a specific suspect,
Uh-huh.
but that suspect seems impossible,
Okay.
it might be time to consider that the initial assumptions about the case were wrong.
Okay, I like that.
Yeah.
So in Barnes's view, the fine-tuning is like that impossible suspect,
Right.
suggesting that our current understanding of the universe might be incomplete.
Exactly.
Right, and this is where the philosophical implications of this whole fine-tuning debate really come to the forefront.
Absolutely.
If the universe is truly as fine-tuned as Barnes suggests,
Right.
it forces us to confront some really profound questions about purpose and design.
It does.
If the universe wasn't meant for life, why is it so perfectly suited for it?
Right.
It's a question that's puzzled thinkers for centuries.
Yeah, for sure.
And even with the multiverse hypothesis,
Yeah.
the question of why still remains.
It does.
If there are infinite universes, why does ours happen to be one that supports life?
Right. Right.
Is it pure chance or something more profound?
That's the big question, isn't it?
It is. That's what makes this whole debate so captivating.
It is, absolutely.
It pushes us to the very limits of our scientific knowledge.
Yeah.
And forces us to grapple with some of the biggest questions about our very existence.
It's a humbling and exhilarating journey.
It is. It reminds us that even in a universe that's potentially teeming with other worlds,
Right.
our ability to ponder these questions makes our existence truly special.
Absolutely. The fine-tuning debate highlights the incredible power of human curiosity
Yeah.
and our unwavering desire to understand the cosmos and our place within it.
And speaking of our place in the cosmos,
Yeah.
let's shift our focus to another fascinating aspect of this debate.
Okay.
It's the why now problem.
Okay.
So it delves into this curious observation that
Uh-oh.
we exist at a time when the densities of matter and dark energy are roughly equal,
Right.
which seems like a really improbable coincidence given the vast timescale of the universe.
Yeah, it's a head-scratcher.
It is.
It really is.
So this apparent coincidence has led some to propose this concept of observer selection.
Okay.
Suggesting that we observe the universe at this particular time because it's the only time when observers like us could exist.
It's a mind-boggling concept.
It is.
It really is.
It implies that our very existence might be intertwined
Right.
with the universe's specific properties at this particular moment in time.
Yeah, we're not just passive observers. We're part of the story. Yeah.
And this leads to the idea of anthropic reasoning,
Okay.
which suggests that the properties of the universe must be compatible
Right.
with the existence of observers.
Yeah, it's a fascinating concept
It is.
that challenges our understanding of the universe's objectivity
Yeah.
and raises questions about whether our observations are inherently biased
Right.
by our own existence.
It's a lot to wrap our heads around.
It is.
But I think that's what makes this whole deep dive so rewarding. We're
Yeah.
exploring ideas that go beyond, textbook science
Absolutely.
and touch on the very nature of reality
right.
and our place in this grand scheme of things.
Well said.
Yeah, it's pretty amazing.
It is. It is. Wow.
I think what makes this whole debate so compelling
Yeah.
is that it's not just about the science,
Right.
It's about the philosophical implications.
Yeah, absolutely.
We're not just talking about equations and constant. We're talking about the very nature of existence and our place in, the cosmic scheme of things.
It's deep stuff.
It really is.
For sure.
So whether the universe is fine-tuned by, chance,
Right.
necessity, or
Yeah.
design, the very fact that we're here,
Right.
able to even contemplate these questions,
Yeah.
is a testament to the universe's remarkable ability to give rise to, complexity and consciousness.
It's pretty amazing when you think about it.
It is. It's a very humbling realization.
It is.
We're not just passive observers. We're a part of this grand cosmic narrative.
Yeah, we're active participants.
Yeah, the story that's been unfolding for billions of years, leading to the emergence of life
Right.
and ultimately us.
We're part of something much bigger than ourselves.
We are.
Yeah.
And I think that realization comes with a sense of responsibility, too.
Absolutely.
You know, we have a duty to, like, continue this legacy of, you know, exploration and discovery
It's a torch we're carrying.
that has brought us to this point,
Yeah.
the call to action.
It is.
Inspiring us to be, you know, worthy inheritors of this incredible cosmic legacy.
I like that.
So as we wrap up our deep dive here,
Yeah.
what are some of the key takeaways that you hope, you know, our listeners will carry with them?
Well, I think the most important takeaway is that, this whole fine-tuning debate,
Yeah.
it's not about finding a definitive answer.
Okay.
It's about, like, embracing the mystery,
Okay.
the wonder,
Yeah.
and the ongoing pursuit of knowledge.
Yeah, it's about the journey, not just the destination. It's
Definitely.
about engaging with these, like, deepest questions about the universe and our existence.
For sure.
And recognizing that, you know, the journey of discovery is just as important as the destination.
Well said.
It's a reminder that even as we uncover more about the universe,
Yeah.
there will always be more to explore.
Oh, shucks.
Yeah.
So if this deep dive has, sparked your curiosity,
Yeah.
I encourage you to continue exploring these ideas.
Absolutely.
Read the full articles, research papers, all that good stuff.
There's so much out there to discover.
There is.
Yeah.
And never stop asking questions.
That's the key.
It is, who knows what incredible discoveries await us on the horizon, right?
Exactly. The universe is full of surprises.
It is. All right. So until next time, keep looking up, keep those minds curious.
Stay curious out there.